Hello Year 10. Today we are finishing off our topic, and the last section that we are working on is solving exponential equations using logarithms. When solving a simple exponential equation, like 2 to the power of x equals 16, we know that the solution is x equals 4, because 2 to the power of 4 equals 16. But solving something like 2 to the power of x equals 10 is trickier, because we know 2 to the power of 3 is 8, 2 to the power of 4 is 16, but 10 is somewhere in between those two numbers, which means the answer is some decimal that is a lot harder to work out in our head. So we're going to solve these kinds of equations by using logarithms. Now, this little thing in the box here is a derivation of the formula that we are going to use, and it says here, using a base 10. If we start with an equation in the form a to the power of x equals y, okay, what we want to do is we want to take log base 10 of both sides. So here's the a to the x is equal to y, and we're just doing log base 10 of each of those things. So log base 10 of a to the x and log base 10 of the y. Now, using one of our log laws, the power of x here can come down to the front, and that's how we get this next line. X in front of log base 10 of a is equal to log base 10 of y. Therefore, if we want to get the x in this equation by itself, we are going to divide the log base 10, this log base 10 of a, over to the other side, and we finally get this formula here. X is going to be equal to log base 10 of y over log base 10 of a. We call this the change of base formula. Okay, so to solve using a base 10, we're going to evaluate each of these to 3 decimal places. Okay, so if I want to change this exponential into a logarithm, I can do a sliding base, which means the x is going to stay on the left-hand side. We slide the base 2 across to the other side of 11. Okay, so there's our logarithm, log base 2 of 11. Now, unfortunately, that's not one we can do in our calculator. We can do base 10s in our calculator. So here is where we do our change of base. We are going to change the base of the logarithm to be a log base 10, and it will turn into the fraction, this formula that we've used up the top here. It'll be log base 10 of the 11 over log base 10 of the 2. So it's always whatever the base is, which is 2 in mine, will be the number on the bottom of the fraction, and then the other number, the 11, will be the number on the top of the fraction. You can use this to change the base into any base you want, but our calculator can do a base 10, so that's why we're doing that. So now in the calculator, we type in fraction. We use the log button for log base 10 of 11, close bracket, over log button again of 2, close bracket, equals, and we're going to do 3 decimal places, which gives us 3.459. Try that again for part B. The problem with part B is that we have this 200 at the front here. So I want to get rid of that 200 by dividing the 200 over to the other side. That will give me 0.85 to the power of x equals 50 divided by 200 is 0.25 as a decimal. You could leave it as a fraction, but I already had a decimal on the other side. Okay, now I'm going to slide the base. The x stays where it is. We slide the base across to become a log base 0.85 of the 0.25. Okay, because we can't do a log base 0.85, we're going to do a change of base now, which means we use the fraction formula where we do log base 10s on the top and log base 10 of the bottom. The number at the end of the logarithm on the top will be the 0.25, and the base of our original log goes on the bottom. Typing that in the calculator, We do our fraction button again. We have log base 10 of 0.25, close bracket, over log base 10 of 0.85 equals 8.530. Part C. Let's do another one. 3 to the power of x equals 10. First move, we are going to slide the base 3 over, so it's log base 3 of 10. Then we are going to use the change of base to make it a log base 10 of 10 over log base 10 of 3. Typed in the calculator. Fraction log base 10 of 10 over log base 10 of 3. Coincidentally, I could have simplified that further before I put it in my calculator, because log base 10 of 10 is just equal to 1. So that would be a slightly more simplified version, but either way, I'll get the same result, which is 2.096. Okay, part D. First of all, divide the 20 over to the other side to get rid of that. So we have 1.2 to the power of x is equal to 60 divided by 20, which is 3. Then, sliding the base, we will have x is equal to log base 1.2 of 3. Then, doing the change of base, we want to do log base 10 of the big number 3 over log base 10 of 1.2. In the calculator, we get log of 3 over log of 1.2 equals 6.026. Question 2 on the next page. The half-life of a substance is the time it takes for the substance to reduce to half its original mass. We want to round these answers to the nearest year. Find the half-life of a 10 kilogram rock if its mass reduces by 1% per year. Now, thinking back a few topics ago, we learnt some formulas for when things were either growing or reducing, and the one where it's reducing looked like this. A equals A0, 1 minus R over 100 to the power of n. Now, the R is the percentage that's reducing by, so that's going to be the 1% over here. The 10 kilogram rock is the starting amount, and because it's a half-life, it means that the amount that we're finishing with is going to be half of that, which is 5. So we have 5 equals 10 bracket 1 minus 1 over 100 to the power of n. And we are trying to solve this to find that power of n. Now, dividing the 10 across the other side, 5 divided by 10 is a half, or 0.5. And then fixing up that bit in the bracket as a decimal, that is 0.99 to the power of n. There's the exponential equation. Now we're going to do our sliding base. So the n, I'm going to move it over to the left, but I'm going to be sliding the base of 0.99 over to the logarithm of 0.5. Then do a change of base so I can make it a base 10, which I can put in my calculator. So log base 10 of 0.5 over log base 10 of 0.99. Forgot to close the bracket. Watch out for that error if you forget to close your bracket. There it is, so 68.967 years. But remember, we want the nearest year, so we're going to round that to 69 years. It will take 69 years for the 10 kilogram rock to reduce to half its size, which is 5 kilograms. Okay, in part B, we want to find the half-life of a 20-gram crystal. So that would be the A0. If its mass reduces by 0.05%, so that will be my R. Same formula as last time. A equals A0, 1 minus R over 100 to the power of n. If I'm starting with 20 grams, then the A is going to be 10. It will be half of it. Then 1 minus 0.05 over 100 to the power of n. Dividing the 20 over, we get 0.5. So when it's a half-life, notice in part A we had the 0.5 here. You always should get 0.5 on that side when you're doing the half-life of something. Then 1 minus 0.05 over 100 is 0.9995 to the power of n. Let's do our sliding base. N equals log base 0.9995 of 0.5. Then a change of base, we make it a base of 10 of 0.5 over log base 10 of 0.9995. And in the calculator, log 5 over log 0.9995 is 1,385.9, so we round it to 1,386 years, so quite a long time. Okay, there's your last exercise, exercise 3K, and then you also have a chapter review there for you too.